Hey guys, my name is Tom, and in this video I am going to walk you through the procedure of checking whether given 3 points you have a right triangle. This is a common kind of exercise. So let's take a look at what we have. So we have 3 points. And let's make this bright so you can see it. So point 1 is given as follows. It has the coordinates 0, 0, 0. Okay. Point 2 has the coordinates given by 2, 2, 1, and point 3 has coordinates given by 2, -4, and +4 as follows. So these are our 3 points, and we want to check what kind of triangle is made when we connect these points using line segments. So first let's do this. Let's find the distance from P1 to P2. So the distance from P1 to P2. Okay, that is what we are finding. Let's place a little bar above that. And we're going to plug this into the distance formula so we can find the length of that segment. So let's do that right now. So it looks like this. Okay, so that's the square root symbol, and then you have the 2 from here minus the 0, so that gives just 2 squared. You add to it this 2 minus the 0, so that's another 2 squared, and then you add to that 1 minus 0, which is 1 squared. Now we simplify this expression, so we have square root of 2 squared, which is 4, plus 4 plus the 1. So all of this now equals the square root of 9, which of course is equal to 3. So one of the lengths of our triangle, the one connected between by P1 and P2, that is equal to 3. That's one of the legs of our triangle. Now let's apply the same concept to the distance between P1 and P3. So P1 connecting with P3. Okay. So let's apply it. And the same thing holds. 2 minus 0 is 2 squared. -4 minus 0 squared is just -4 squared, and then 4 minus 0 of course is just as before 4 squared. Let's simplify this. This is now 4 plus 16 plus another 16. So this now gives 16 and 16 is 32, and 4 is 36. And the root of 36, of course, is 6. And now we come to finding the distance between P2 and P3. So that looks like this. P2, 3P3. Okay. So now this one's a little different. We'll have to do the purple 2 minus the blue 2, right? So 2 minus 2. I'm going to color code here. It will be helpful. 2 minus that 2, and the whole thing here will be squared. Okay, now we add to this the -4 minus the 2, so -4 minus that 2, and the whole thing will be squared. And then 4 minus 1, so 4 minus that 1, and the whole thing is again squared. Now we work on this as follows. Well, 2 minus 2 is 0, so all that ends up being here is 0 squared, which is 0. So in other words, 2 minus 2 squared disappears, plays no role. So all that remains is -4 minus 2, which is -6 squared. 4 minus 1, of course, is 3, so you square that. So now we have 36 plus 9, which is 45. Now we apply a basic property of square roots. So we have this written as 9 times 5 square root, which is the same as the root of 9 times the root of 5, which is the same as 3 times the root of 5. So these are the three sides of our triangle. Let's circle them, put them in boxes. One of them is the 3, one of them is 6, and now the third side I will enclose in this color is 3 times the root of 5. Now that we have the three sides, we can determine whether we have a right triangle by simply checking whether this squared plus this squared equals this one squared. Okay? And if that is the case, then we do have a right triangle. We don't have an isosceles triangle because you can tell right, these are different when this one is different from this, which is different from this, which is different from the first. Okay? So let's apply our understanding as follows. 3 squared plus that's 6 squared. Okay, and does this equal now the root of 3 times 5 squared? Okay, we have to check whether this is a true statement. Well, the first one is 9, and to it we will add 36. Now, the square of 3 times the root of 5 is the same as 3 squared times the root of 5 squared. I'm being very detailed here. So you're distributing the 2 over to the 3 and the root of 5. Then we have 9 plus 36, which is 45 on the left side. And on the right side, we have 9, and then the square root of 5 squared is just the 5. And of course, guess what? Are these equal? They absolutely are. Which means we can conclude that we have a right triangle. So to draw a little picture, perhaps we could do this. Draw a little triangle. Okay, mark the angle as 90 degrees here. Label this leg perhaps as our 3. Label the longer leg here as 6. In the hypotenuse, we could label as 3 times the root of 5. That is the whole exercise. Thank you for watching.